I feel so bad, I got a worried mind. I'm so lonesome all the time since I left my baby behind on Blue Bayou.
Okay, we're going to finish off section 3.4, which is on factoring x squared plus bx plus c. And so far, just a quick review here, we've done two types of factoring. The first type we did a couple days ago was remove a GCF. So for example, here's a trinomial, but it's not of the simple trinomial type. How come? Well, look at, we have x squared and y fourth, x cubed y, x fourth. That does not look right. So the best we can do is remove a greatest common factor. How do we do that? We look at the three terms, because there are three here, and we ask what's the biggest thing we can take out of each one. So if I look at the numbers, I've got 5, 25, and 10. I can take a 5 out. If I look at the x's, I've got 2 of them, x squared, 3 of them, x cubed, and 4 of them, x to the fourth. Remember, you take the smallest exponent because you want to know what's the most you can take out of each term. Well, the most you can take out is 2 out of each one. We look at the y's, 4, 1, and 4. The most you can take out is 1. So this right here is your GCF. Now, you don't stop there. Now you put your bracket and you ask yourself, what do you multiply 5x squared y by to get 5x squared y to the fourth? And you still need 3 more y's. Minus 5, because 5 times negative 5 is negative 25. You need 1 more x, but you've already got the y, so that's fine. And then 5 times 2 is 10. You need 2 more x's, so x squared. And you need 3 more y's, so y cubed. Okay, I did that pretty fast, but that is review, so hopefully you understand that. Alright, the second type of factoring we did was last day. We did simple or simpler trinomials, although I'm hoping someone can come up with a better name. It's kind of boring, simple trinomials. How do you do that? Well, first of all, you need to recognize it's a simple trinomial, and it is. Look at x squared, x, and then the constant. That's perfect. That's exactly the sort of thing we're looking for. So how do you do this? Well, you're looking for two numbers that multiply to 15 and subtract, because of that subtract sign right there, subtract to 2. That's if you're using my trick. If you're not looking for using my trick, then what you'd be looking for is two numbers that multiply to negative 15 and add to positive 2. But if you're not so good with integers, use the trick. Two numbers that multiply to 15 and subtract, because of that sign right there, to 2. Alright, let's do this. We know it's going to be bracket, 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 bracket. Since it's x squared, we know it's going to be x times x to get that x squared. Two numbers that multiply to 15 and subtract to 2. Well, let's make our list of numbers. 1 times 15 equals 15. 2, no. 3, yes. 3 times 5. 4, no. 5, we already said 5. We're done. This is the whole list. Which of those pairs subtracts to 2? It's this one. These subtract to 2. Put the big number in the first bracket, small number in the second bracket. Take the first sign here and bring it down. Got to think about the second one. Is it a positive times a positive gives a negative, or positive times a negative gives a negative? It's a positive times a negative. This is our answer. Okay? Those should both be pretty good. We've done a couple sections on those. Now, sometimes, like in today's work, you're going to be able to do both of those. And the key point is you want to, when factoring, always try to remove the greatest common factor first. You might not be able to. This is why I put try. You might try to take the greatest common factor out, but you can't do it. But you want to at least try, because if you can remove a greatest common factor, you want to do it before you do anything else. So in today's work, you can bet you're almost always going to be able to remove a greatest common factor. That's why I'm focusing on it here. So let's try some. If we look at this question right here, the first thing we want to do is we want to remove a greatest common factor, or at least try. What's the greatest common factor there? There's 3 terms, and the biggest thing I can divide them all by is, the biggest thing I can divide them all by is 3. Now, you don't need to write GCF equals 3, but just so you know later when you look at your notes, I'll write it right there. So since the greatest common factor is 3, we write 3, and then I ask myself, what do I multiply 3 by to get 3x squared? By x squared. What do I multiply 3 by to get negative 3x? Negative 1x, or just negative x. What do I multiply 3 by to get negative 90? Negative 30. There you go. We removed the greatest common factor. But hold on a second. Before we go to the next question, take a look at what's left in the brackets here. Do you see what that looks like? That looks like a simple trinomial. it looks like something we can factor. So that's exactly what we're going to do. We're now going to look for two numbers that multiply to 30. And what's this all about? What do they do here? They subtract, because of that sign there, subtract to, what's the number here? 1. Subtract to 1. If you're not using tricks, you're looking for two numbers that multiply to negative 30 and add to negative 1. If you don't use my tricks, it's always add, right? It's either add to negative or add to positive. So numbers that multiply to 30, I'll make my list. 1 and 30, 2 and 15, 3 and 10, 4, 5 and 6, and that's it. And we want a pair that subtracts to 1. The subtract to 1 right there. So if I just look at this highlighted part, if I was going to factor that, I would go bracket, 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 x and x. Big number first, 6, small number second. Drag down that first sign, minus. Is it negative times a negative equals a negative, or negative times a positive equals a negative? Negative times a positive. Now, oftentimes people feel all happy about themselves. They've just finished the question, right? No, they have not. Don't forget to drag the 3 down or keep the 3 up front. That is one of the factors. In this case, there are 3 factors. There's 3, x minus 6, and x plus 5, and you need to include them all. And that's what you're looking for in every one of these questions. You want to look for a grace common factor, take that out first, and then factor the rest. Now remember, you won't always be able to take out a grace common factor usually, but in today's work you probably will. So let's keep going. What's the greatest common factor here? 5. Should I write that down? Greatest common factor equals 5. So you take out the 5, what's left over? 5 times x squared equals 5x squared. 5 times 3x equals 15x. 5 times negative 18 equals negative 90. Okay, look at the part in here. Can you still factor that? Yes, you can. You won't always be able to, but in this case you can still factor it. So what are we looking for? Two numbers that multiply to 18 and subtract to 3. Alright, let's make our list. Let's do it in blue so we can actually read it. 1 and 18, 2 and 9, 3 and 6, 4, 5, so that's it. Those are all of them. Which of those ones subtract to 3? Those ones right there. So what we end up with is x and x. Big number 6, small number 3, drag down the sign. Positive times a what equals a negative? Positive times a negative. Don't forget to bring the 5 along for the ride, otherwise you just got the question wrong. Happens all the time. People forget the greatest common factor, but that greatest common factor, if it took 5 more steps to do this, that greatest common factor would just tag along for the ride. Okay, next one, greatest common factor here. Do you remember when we talked about greatest common factors before, I mentioned that if your leading coefficient, if the first term right here is negative, in this case negative 2, your greatest common factor should include the negative sign. So in this case, your greatest common factor is not going to be 2, it's going to be negative 2. Why do we do the negative? You're going to see in a second. Because if we make negative 2 our greatest common factor, what you're left with is x squared. Now be careful. Negative 2 times what equals positive 28? Negative 2 times negative 10x equals positive 20x. And negative 2 times what equals negative 42? Negative 2 times positive 21 equals negative 42. So be careful with your signs. Now, why do we take out the negative? Because now the part that's left inside here is in perfect simple trinomial form. If you didn't take out the negative, you'd have a negative x squared, and that's not the form. You want it to be positive x squared in these simple trinomials. You want an x squared, an x, and then a constant, and that's exactly what we have right here. It's time to factor again. Can you factor this bit right here? Yes, you can. You're looking for two numbers that multiply to 21 and add to 10. 21, not too many numbers multiply 21. 1 and 21, and 3 and 7. Which one of those add to 10? The bottom one. Why is it always the bottom one when we do this? I do not understand. So, we're going to do bracket, 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 x, x. Our numbers are 7 and 3. Big one first, small one second. Drag that sign down. A negative times a what equals a positive? A negative times a negative. Don't forget, the negative 2 comes along for the ride. And we're done. Okay, same thing here. There is a greatest common factor in this one. Often people think because there's no number out front, there's not a greatest common factor. There's always a greatest common factor. It could be 1, but in this case the greatest common factor is negative 1. So you want to include that negative 1, or just negative. But I'll put negative 1 for now. So greatest common factor equals -1. So what's left? X squared, because -1 times x squared is negative x squared. -12x, because -1 times -12 is positive 12. And positive 32. Could have left a little more room here, couldn't I? -1 times positive 32 equals -32. Okay, now we look at the part in brackets. I'm not going to highlight it this time. And we're going to factor that. What are we looking for? Two numbers that multiply to 32 and add to 12. So 32. 1 and 32, 2 and 16, 4 and 8, and that's it. Which ones add to 12? Are you kidding me? The bottom ones again. So what you're left with is, or what we do now is put our brackets, x and x. Our numbers are 4 and 8, but make sure you put the 8 first, big number first. If you use my trick, you don't have to if you're not using the trick. Drag down the negative sign. Negative times a what equals a positive? Negative times a negative. Okay, be careful. This thing needs to come along for the ride. You could put -1, but if you want to look more mathematical, you just put negative. It's simpler. We like that. This is your answer right here. Okay, next page. Now on this page you're going to see that the greatest common factors can get pretty messy. So what's the greatest common factor in this case? Well, you can take out a 4 in each of them. You can also take out a no x's because there's no x here. So the x's are 2, 1, and 0, and the smallest number is 0, so no x's. But y squared, and y squared, you can definitely take out a y squared. Greatest common factor is 4y squared. So we have 4y squared, and what are we left with? X squared, not surprising, this is going to become a simple trinomial. Take away 6x, yeah, that should be right, x squared and then x, and we should get a constant here. Take away 16. It worked. Take a look here and see if we can factor it. Two numbers that multiply 16 and subtract to 6. 16 has quite a few. 16 has 1 and 16, 2 and 8, 4 and 4. Is that it? Oh, I thought I had more than that. We're looking for two numbers that multiply 16 and subtract to 6. Yeah, it's not the bottom one. It's this one. So, bracket, 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 x and x. Big number's 8, small number's 2. Bring down the sign. Negative times a what equals a negative? Negative times a positive. This whole greatest common factor comes along for the ride. 4y squared. Okay, what's the greatest common factor this time? A lot of people say the greatest common factor is 10 here, but that's not the greatest common factor. The greatest common factor is 10, and you can also get an x. There's 3 here, 2 here, and 1 there. You can get an x out. So 10x is your greatest common factor. What's left? X squared, of course, because it's going to become a simple trinomial, plus 10x times what equals 10x squared, plus 1x, or just x. And 10x times what equals negative 20x? Negative 2. So we're looking for two numbers that multiply to 2 and subtract to 1. 2, well, there's not many factors of 2, 1 and 2. Sure hope it works. Do they subtract to 1? Yes, they do. So bracket, 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 x and x. Big number's 2, small number's 1. Bring down the sign. Positive times a what equals a negative? Positive times a negative. 10x comes along for the ride. Alright, you're probably getting tired of this. They're all the same, aren't they? Here, there's a little bit different here. These last four are definitely different, so watch carefully. You do need to know these two for sure, and then these bottom two are kind of bonus. They're more grade 11 work, sorry. So, what do you notice about this one? If we try to take out a greatest common factor here, you'll notice, well, what you'll probably say is, there is none. There always is a greatest common factor. The greatest common factor is 1. But if your greatest common factor is 1, it doesn't make any difference to pull out the greatest common factor. You'll just be left with the same thing. So don't take out a greatest common factor of 1. That's ridiculous. But we're left with this. This doesn't totally look like simple trinomial form. Why? Because of this. Exactly. Why? I've answered my own question. It doesn't look like it because of this y and this y squared right there. So what do we do with that? Well, here's what I want you to do. I want you to ignore it for now. I want you to pretend it's just x squared minus 8x plus 16. If it was that, could you answer this? What you'd be looking for is two numbers that multiply to 16 and add to 8. 16, 1 and 16, 2 and 8, 4 and 4. Is there two numbers that multiply 16? Here they are. And add to 8? Yeah, the bottom ones again. 4 and 4. So we could do this. We could do, we're ignoring the y's for now, right? We could do bracket, 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 x and x. Our numbers are 4 and 4. Do me a favor and put the 4 just a little bit over to the left. Don't put it right next to the bracket. And again, a little over to the left. What are our signs? Drag down the negative. and then a negative times a what equals a positive? A negative times a negative. Any ideas why I left a little space here? Because what's going to go in there is y and y. And now you have the answer. Now you might be like, well, how do you know that? How do you know that it's going to be like that? And all I can really say about that is, well, that's the pattern, for one thing. And the other thing I do is say, let's check it and make sure it works. And hopefully that'll help you see why you have the y there. So let's check this. I'm just going to rewrite it. X minus 4y times x minus 4y. So we're going to do mountains and valleys. So we do x times x is x squared. X times negative 4y is negative 4yx, or we like to put them in alphabetical order, xy. So negative 4xy. Negative 4y times x is another negative 4yx, but we like to put it in alphabetical order, negative 4xy. And negative 4y times negative 4y is positive 16y squared. You can combine these, so you get x squared, take away 8xy, plus 16y squared. And you'll see that this is exactly the same as what you started with. So you'll be able to do this as long as you have that extra letter, as long as it's squared here and there's just a single one of them there. You'll always be able to do this, is just ignore it and then plop it in at the end like that. I hope that makes sense. I will do another one here. By the way, one other thing about this question, do you see how it's x minus 4y times x minus 4y? It's exactly the same thing, right? So if you want to get exactly totally completely factored, you'd actually go one more step. You'd actually say that x minus 4y squared, right? 5 times 5 is 5 squared. M times m is m squared. Then x minus 4y times x minus 4y is x minus 4y all squared. We'll talk more about this in a couple classes, so don't worry about it too much, but just a heads up that you could write it like that as well. And that is in a simpler form than this one is. Okay, greatest common factor of this one. Is there a greatest common factor? Yes, there is. You can take out a 6. Can't take out an x because there's no x here, but you can definitely take out a y. How many? There's 1 there, 2 there, and 3 there. The most you can take out is 1. So 6y is our greatest common factor. What's left? You'd have an x squared here. You'd have plus 3x. You also need another y, so 3xy. Then you'd have take away or negative 10. How many y's do you need? Y squared. Do you see this is exactly what, like the last question? You have extra letter squared and an extra letter to the first power here. So you're going to be able to do that same thing. So the way I like to do it is just ignore those highlighted ones for now. So we're just going to look at the x squared plus 3x take away 10. So we're looking for two numbers that multiply to 10, 1 and 10, 2 and 5, that's it, and subtract to 3. It's these ones. So bracket, 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 x, x. Our numbers are 2 and 5. Put the big one first, leave a little space at the end. 2, sign comes down, plus, positive times a what equals a negative, positive times a negative. But we have this highlighted bit. How do we get that? By adding a y and a y. Are we finished? No, the greatest common factor comes along for the ride. There you go. Okay, that is everything you must know this year. If you want to get a little bit ahead and challenge yourself, we got these things. Take a look at this one. M plus 2 times x squared plus 11 times m plus 2 times x plus 24 times m plus 2. What keeps showing up there over and over and over? M plus 2, m plus 2, m plus 2. Guess what your greatest common factor is? The greatest common factor is m plus 2. So what you're going to do is take that m plus 2 out front, keep it in brackets, got to keep it in brackets, and what's left is m plus 2 times what equals m plus 2x squared? X squared. M plus 2 times what equals 11, m plus 2x, 11x. And m plus 2 times what equals 24, m plus 2, 24. Oh, it worked out again. We have a simple trinomial in here. So you're looking for two numbers that multiply to 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and add to 11. Those ones. So we can do our brackets, x and x, big number first, small number second, drag down the plus sign, positive times a positive equals a positive, and you still have this greatest common factor that comes along for the ride, and there's your answer right there. That one's not too bad. This one's a little more complicated because at first it looks like it's exactly the same. There's a y plus 3 squared, there's a y plus 3 here, there's no y plus 3 here. What do we do? Well, if you look at this for a little bit, do you see that if we, instead of having y plus 3, if this was actually x squared, and this was actually x here, then we'd have exactly a simple trinomial of this type here, where we have the extra letter. That would be if it was an x and an x here, but it's not an x and an x. It's a y plus 3 and a y plus 3. So you know what you can do? This is a little advanced here. You can say for the momentarily, let's say, okay, this is too confusing having the y plus 3 and the y plus 3. So what I'm going to do is I'm going to call that y plus 3, I'm going to call it x. So I'm going to say, what we usually say in math is let. I'm going to let x equal y plus 3. Okay? So wherever I see y plus 3, what I'm going to write instead is x, because I'm saying that they're equal to each other. That's fine, I can do that. So y plus 3, instead of saying that, I say x squared minus 9a, oh, there's another y plus 3, so I say x plus 20a squared. Good, that looks more encouraging. Now if you look, you have an a here and an a squared here. So this is of the type, as I said, it's of the type back here. Let's just ignore those a's for now. So we're looking for two numbers that multiply to 20 and add to 9. 20. 1 and 20, 2 and 10, 4 and 5. Which of those add to 9? These ones. So let's do our bracket, x, 5 and 4. Drag down the negative sign. Negative times a what equals a positive? Negative times a negative. But we have the extra letter, so don't forget to put that extra letter a and a in here. Did we have a greatest common factor we have to drag down? No, there was no greatest common factor. So are we done? No. Why not? Because remember we temporarily, maybe I should write that even here, temporarily let x equal y plus 3 just to help us simplify the question. But now what we have to do is we have to say wherever there was x here, we have to write y plus 3. So we're going to substitute that in here, and we're going to substitute that in here. Substitute. So I see an x here. What I write instead of x? I go backwards this time. Wherever I see x, I put y plus 3. So I have y plus 3 minus 5a times, oh, there's another x, y plus 3 minus 4a. If you give me that, I'll give you all the marks. If you want to do it absolutely correct, you should probably put the a's first, then the y's, then the 3. I don't really care. But that'd be negative. Actually, you know what I would kind of prefer? Y minus 5a plus 3, and then y minus 4a plus 3. Then we don't have to lead with a negative 5a. Anyway, this is fine. Usually what you do is you put that constant last, so that's why I would move the 3 over here. That's it. We have a couple more types of factoring to go. You've now learned 2 types, and you've learned how to do them both together. We got 2 more types to go. Halfway there. Keep learning them. Very, very, very important.
I'm going back someday, come what may, to Blue Bayou, where you sleep all day and the catfish